Hello, and welcome to the lab for computer architecture. This is Nachum Danzig. I'm a teacher at the Jerusalem Academic, or the Lave Academic Center. This is lab 3.1, which we are in MIPS making a bubble sort in assembly language for MIPS. Now, what this exercise requires of us is to put A0 as a pointer to the array of data, which is going to be of size word. Each data is a word length. And the number of data is going to be in A1. In other words, if there's 10 elements in our array, A1 will be 10. Now, bubble sort usually requires two loops, a loop within a loop, and you've hopefully learned that algorithm in your course Introduction to Computer Science, and hopefully you remember it. Now, doing a loop within a loop is totally doable in assembly, but it can get a little bit confusing. So I want to show you how to do bubble sort with a single loop, and it still will be bubble sort, which means it will not be any more efficient than bubble sort is normally. Bubble sort is the order of efficiency is n squared. In other words, there's n elements going to take n squared comparisons. So we're not going to make it more efficient, but we're going to do it in one loop, which will make it a little bit easier to program, especially in assembly. You may never have seen this before, but let's take a look. So, just a second. Here we go. And there. So, this is bubble sort in a single loop. Now, what have I done? I have a counter I and j, just like in regular bubble sort. They're in the outer loop, both of them. And let's start looking at I. I starts off at 0, and it goes up by 1 each time. And look down here at the swap section. Every time I increment I, I'm going to compare I to I plus 1. And if it's out of order, in other words, if the first I, if array of I is less than array at place I plus 1, is greater than, that means it's out of order. In other words, if I got 100 over here and 30 over here, it's out of order. It should be ascending. We're assuming that it's an ascending bubble sort. So we want to put an ascending order. So if it's out of order, if the first element, if array at location I is greater than array at location I plus 1, then we're going to have to swap them. And the swap procedure is pretty basic. You should remember it. You just do temp equals the first one. The first one is going to be copied into it. It's going to be copied to the second one, and then the second one will be equal to temp. So we've switched the order, and we continue on incrementing I. And so far, we're just going to go through all the i's one time. But now we have to do this multiple times. So how do we get the second loop? So for that, I use j. And j also starts at 0. Now, before I get to j, actually, we'll talk about this I. If this I keeps going up and up and up, and I don't even check in my for loop, I don't check for I. It just says j is less than n minus 1. N, of course, being the size of the array. If there's 10 elements, n will be 10, and n minus 1 will be 9. So I'm just checking if j, as long as j is less than 9. But I'm not checking what about I, so it'll be infinite. So we have a catch. Here, we say if I equals n minus 1, which in our case is 9. Now, if we've got to the end, if we've gone through every single element. Now, why did I stop at n minus 1? Because I don't want to check. If I stopped at 10, then I'd be checking too far. So if I've reached the end, before, I want to stop before. If I've reached the end, if I've reached 9, then it's time to stop and go back to the beginning. So what do? I set I equal to negative 1. Then I do continue. Now continue means skip this section of the code and go back to the beginning. And I will again go up by 1. So if I set it to negative 1, that will put it up to 0. So now it's 0 again. And I continue going through my i's. Okay. So my I is going to go back to 0 and go up, 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 up till it reaches 9 and then go back to 0. I'm just thinking now, maybe it should be 8. You can think about that. Maybe it should be 8 because I'm comparing it to the 0. In other words, if it's equal to 8 already, I want to stop because well, when will it get to be here 9? It'll get to be, this is correct, because if it gets to here to be 9, that means it's already done the loop again, and it's incremented it, and it's 9 now, and 9 I don't want to do, because that would be comparing it 9 to 10, and 10, there is no 10th element in the array. There's 10 elements in the array, but the 10th element is 9. So if I already did 8, and now I went up to 9, it means that I'm done. So it is correct to have it at this place. Now, okay, so it's going to go on forever. How am I going to stop it? So each time I reset I to 0, or to -1 in this case, I'm going to count j up by 1. I'm going to increment it by 1. So that means if I do this 10 times, eventually j will no longer be less than n minus 1. So that's how we get n times n. In other words, I is going to do n times. And how many times am I going to do I? J times. And j is also going to be n times, or n minus 1 times. So here I have a loop within a loop with only having one for loop. I don't have to have another for loop. And that's going to make our life easier when we go to assembly. So get this, let's look at this again. I have a j, which is controlling how many times I do my I loop. And the j only increments once every n times. Now, there's only when I reaches the end, then I increment j. And eventually j will stop us and end the whole program. But in the meantime, I will go from 0 to 9 or 8, depending on how you look at it. Okay, so that is what we want to do. Now, how are we going to do that in assembly? So first thing we got to do is we got to create an array. Now, I've made an array here, data array, word length. So notice each number here is 4 bytes long. It doesn't really matter. I could have done it with a byte length, in which case each number here would be 1 byte long. But now they're 4 bytes long because I made it word. And also he said in the question that they should accept positive and negative numbers. So for good measure, I put in some negative numbers here. Also notice that I made the worst possible case. If I wanted ascending, this is exactly descending. 10, 9, 8, 7, 6, and then -1 is larger than -2, and -2 is larger than -3, etc. until -5. So here I have my array going down. Now I'm done with my array, and I need to assign the length of the array to A1. Now why do I do that? Because it says to over here, no, not over here, sorry. It said to, let me get the right page, sorry, excuse me. No, yeah, no, that's 3, here, bubble sort. It said that each data is one word. The address of the array should be stored in A0 and its length in A1. So I'm going to do exactly that. And that's what I've got over here. A1 is the length, and LA says copy the address of this array called array. I just called it array. I could have called it My Little Pony, but I called it array. And A0 will now be a pointer to that array. So far so good. I've got a pointer to the array, I got the size of the array, but I need to do my loops. So how am I going to do it? So let's start like this. If we look at the code again, basically, sorry, I don't like that blue. What we've got here is, I and j start off at 0. Well, every register is 0, so I don't have to do that. And then this check, as long as this is true, what am I going to do? This is the first thing I'm really doing. I'm checking if j is already reached the end. Is already reached n minus 1. So I've got to have a variable called j. So look what we do here. First of all, we have to create n minus 1. So that's what I do over here. I say S2, I just chose S2, he'll be my n minus 1. So A1 is 10. And add 10 to -1, and I get 9. That's n minus 1. Now, it's better to use add as I did here. Oh, this is a mistake, actually. This should be add I. No, I'm in Hebrew. Add I. So, because this is a digit. This is an actual number. So, this is actually more efficient to use add in this way than to use subtract. Subtract a little more complicated, so it's better. Actually, there is no sub I as far as I recall. So unless we can use pseudocode, we have to do it this way. So that's going to be our add. That creates our n minus 1. Now we need to check if j has reached that limit, has reached that end. Again, j, as long as it's less than the limit, continue. Which means if it's equal to the limit, stop. So I'm going to do the opposite. Notice I'm going to do if it's equal to the limit, stop. I'm not going to do if it's less than the limit, continue, because that just means do nothing. But what is the key factor to do when it reaches the limit? End. So that's what I'm going to do over here. If S0, which I'm calling J, now S0, just to prove to you here, S0, his original value is 0 when it starts off at 0. So it starts off at 0 just like it's supposed to, and I'll change it, of course, as time goes, as the program runs. So as long as S2, if S2 has reached the limit, it's equal, BEQ, branch if equal. If S0, which is J, equals S2, which is my limit, then go to end. Now, end is going to be someplace at the bottom. So that's going to mean that if I'm on line 10, I'm for sure have not reached the limit. And that means that I'm over here now at this if. If I've reached the limit, then go to the end. But if I haven't, then go to the next line. And there I check if I is equal to the limit, then do this, which means, again, we can reverse it. If it's not equal to the limit, if it's less than the limit, then don't do this. Then skip over this stuff, right? Only if it's equal to this stuff. So skip over. Skip over if it's less than the limit. That's what that means. Remember, you have to don't get caught up on the way we wrote it in C++. Think about what it means logically. It means if I'm less than the limit, if I'm less than this, if I'm not this, then don't do this. Skip over it. So that's exactly what we're going to do here. And that's what I do here. If it be NE, if S1, which I'm going to call S1, I wrote a comment here, S1 is the I. So if I is not equal to the limit, that S2 that I created over here, then skip over the following code and go to this place called swap test, which is just the name I gave to this swap area, where I test this condition and then swap if needed. So I'm going to have a section like this in my code I'll call it swap test. So if it's less than this, jump to here. Well, that's exactly what this code means. So if it's not equal to this, go to swap test. So if I don't go to swap test, what does this line mean? This line 11, means it does equal. I've reached the limit. Well, what do I got to do at the limit? At the limit, I've got to increment j and reset I to -1. So that's exactly what I'll do. I will reset j. J is 0. 0, right? I mean S0. S0, yeah. So S0 equals S0 plus 1. That's exactly what I want. I increment it. I make it go up. That's what's going to stop my loop eventually. I didn't check for it yet. I didn't check I did. Sorry. Here I checked that eventually S1 will reach S2 and go to the end. Now I also have to set S1, which is my I, to equal -1. How do I set it equals -1? Oh, there's no equals operation in MIPS. I can do, however, add. And add means take 0 and -1. Well, if I add those two together, I get -1. And set that to S1. So S1 will get the value that I want it to do. I reset it. And that's pretty much what I want to show you. I want to also mention something about this ampersand. This is how you make a comment, right? With this hashtag. And then notice how I made the comments. The comments are really to help me remember what I'm doing. It's very important that I remember that S0 is J logic in my other program, and S1 is my I. Now normally we'd give variables better names than I and J, but when we're doing a loop when we're doing just a loop for the sake of looping, like in a bubble sort, we don't need to give it any better, more descriptive names. Sometimes we'll call it count. Sometimes we'll use other names that are. We should always try to be descriptive. Okay, so what am I going to do in swap test? Well, in swap test, I'm going to check if this is less than this, if they're out of order, and then swap. So let's see how I'm going to do that. I'm not going to do it fully, but I'll show you a little bit. So basically what I'm going to have to do in order to compare the two elements in my array, remember I have my array up here. I have to load the words. So in order to do that, I need to load word. I need to do LW. So I'm going to do some kind of LW for one element, LW for the next element, and then I'm going to do an SLT. I'm going to do set less than. I'm going to compare. Is this one less than the other one? And if it is, in other words, if it's in the wrong order, as I should have actually here, I'm going to have to have a branch not equal or branch equal. If they're not in the right order, if they're in the right order, then skip this swapping, this storing, because they're already there. Don't do anything. I loaded them and I checked them and they're in the perfect order. So then I'm going to do skip branch. But if they're in the wrong order, then I'm going to do this swap. Well, actually, it's not a swap, store word. Basically, what I'm going to do is I'm not going to need to use a temporary variable like I did in C++. Remember, in C++ I had a temporary variable. Here, I already have, because I did a load word, I stored them in some kind of variable. I stored the two elements in some kind of variable. I can simply I loaded them into temporary registers. I can just simply do a store word and take them from those temporary registers and put them back into the array in opposite locations. And this branch is going to go to someplace like over here. Let's call it don't swap. That's a great name because this means don't swap. In other words, I'm going to branch if it's not right. In other words, if it is right, if it's in ascending order, then branch to don't swap. Otherwise, do these two lines, which will swap. And then I've got to do this all important line, add I with S1. Essentially, S1, remember what S1 is? Let's go check. S1, here's where comments come in helpful, is our I. That is this I++ here. So I think this actually happens, even though it's written here in C++, it really, if you think about it, it happens as the very last line of the for loop. It does the increment and then comes back here and checks the check. So, I'm going to do that increment over here, S1, add I with some kind of 1 over there, and make it go up by 1. And then I'm going to have to go back to the top, someplace over here, and do it all and continue on. Now, obviously, I'm not going to go. I'm going to go up to here, not to this. I don't need to do these first two lines, but I need to do these other lines. No, I don't need to do this line, but I need to do from this first BEQ. So that's it. That's all I want to show you. That's the basic idea. I use these load words and this set less than. I compare, and then based on the comparison, I decide whether to swap or not, and then I increment, and then I continue on with my checks. And that's basically it. I basically did the whole program for you. I just left you a little bit to figure out on your own. Good luck. I'm sure you will succeed.